Okay. Oh, no. And now for part 2. So these were the slightly harder problems, and I wanted to make a separate video so that you could kind of choose which one you wanted to look at. So this first one, now we're starting to find solutions within a particular interval, and we're going to find all the solutions within 0 to 2 pi, including the endpoints if possible. So notice we have something that looks like cosine squared x minus 2 cosine x minus 3. It looks like a quadratic. So you can either factor it directly, or you could do a little substitution to make it look a little more friendly. So m squared minus 2m minus 3, where m equals your cosine x. And we see that we could factor that into m minus 3, m plus 1 equals 0. And once you have it factored, then you do want to put your cosine back in. So we really have cosine x minus 3, cosine x plus 1 equals 0. And like a normal quadratic, we want to set each one of these factors equal to 0. So that means cosine x is going to equal 3, or cosine x is going to equal a negative 1. So on this side, if we do the inverse cosine of both sides, notice you should realize cosine can never have a ratio greater than 1, so this side is going to give us no solution. But that doesn't mean you have no solution to the whole problem. So we go to the other side, and we're going to have a solution for where the inverse cosine is negative 1. And that's going to be on one of your quadrantal angles. That actually happens at pi plus every time around the circle. So if we look a little visual of that, that's going to happen here, and then every time you go around. And since our solutions are between 0 and 2 pi, our only solution is going to be pi. And that's it for that one. Now, we didn't do the tangent one in class, so I'd like to go through and do this one. So notice you have secant squared minus tan theta minus 1. Again, you always want to choose the squared term to transform, because you can use your Pythagorean identities. So remember 1 plus tangent squared theta equals secant squared theta. So now we are in degrees, and we're going to find all our solutions from 0 to 720. So we replace secant squared with 1 plus tangent squared, and then minus tangent theta minus 1 equals 0. And the 1's actually cancel out, so all we have here is tangent squared theta minus tangent theta equals 0. And we can pull out a tangent theta, pull out a common term. We have tangent theta minus 1. And we still set each one of these equal to 0. So we have tangent theta equals 0, or tangent theta equals 1. So tangent is going to be 0 whenever, remember, your asymptotes fall at 90, negative 90, and 90. So we could just, doesn't really matter which we say. Let's go ahead, since we are looking for solutions from 0 to 720, let's go ahead. Oh, I'm sorry, I just said that wrong, didn't I? Oops. Take that one back. That's going to be your asymptotes. That's not where it equals 0. It's going to equal 0 wherever sine is 0, which is going to be at 0 and 180. So we're going to have 0 degrees plus every multiple of 180, because we're in degrees now. And tangent theta equals 1 at 45 degrees for every isosceles triangle. So that is going to be 45 degrees plus every multiple of 180. All right, so let's first work on getting all our solutions for the 0 degrees. So this one, so luckily it does include the endpoints. So we do want 0. We do want 180, because we're going to go around. Here's 0. Here is 180. We do want 360, because that is within 720. And as we keep going, we're going to keep adding 180. So we do want 540, and we do want the second time around, we are going to want 720. So those would be the solutions that come from the 0 part. Now we're going to have solutions that come with 45 degrees. So that's going to start here and work around. So we have 45 degrees, and then you add 180 to that, and you have 225 degrees, and then you add 180 to that, and you're going to have 405 degrees. So that would, so we had our 45, 225, 405, and then add another 180 to that is going to give you 585. And after that, we would be past our 720. So putting that all together, because you do want to write it in a sequential order, I'm going to kind of bring it down here. This is going to be a long list. First we have 0, then we have 45, then we have 180, then we have 225, then we have 360, then we have 405, then we have 540, then we have 585, and last but not least 720. And those would be all our solutions from 0 to 720. Okay? All right, now for this last problem, and this is the one where we had the quadratic program for. So notice we have two different trig in this quadratic. You have a cosine squared and a sine, and like same as in the last problem, you always want to transform the squared term because you can use your Pythagorean identities. So cosine squared is going to be rewritten as 1 minus sine squared, and then we have plus 2 sine x minus 4, so we're going to set this all equal to 0. Distribute your 5, so 5 minus sine squared x plus 2 sine x minus 4 equals 0, and combine our like terms. So minus 5 sine squared x plus 2 sine x, 5 minus 4 is a positive 1. And now since we are going to use the quad program, it doesn't really matter. I just have a general preference for having a positive lead coefficient, so I'm going to multiply through by negative 1. Minus 2 sine x minus 1 equals 0. So we know that A equals 5, B equals negative 2, C equals negative 1 in our quadratic formula. And here's where I would just go to the program, and you hit the program, you find quad, you hit enter, and then you follow the prompts and enter your ABC, and it's going to give you two answers. So the first answer it's going to give you is 0.68, I'm just going to truncate, and the second answer will be negative 0.289. All right, so that is based on our quad program. Now remember, that's not the answer really to x, that is the answer to sine x. So what we're going to have to do is we're going to take each one of these individually. So sine x equals 0.689. Let's deal with this one first. So that means x equals the inverse sine of 0.689. And so you enter that on your calculator, 0.689. And remember, you're going to have two solutions from this. You're going to have, in this case, 0.760 plus 2 pi n. And our second solution, remember, I'm going to write it up here, is going to be pi minus 0.760. And the answer to that is 2.381 plus 2 pi n. Okay, so we have the two answers that went with sine x equals 0.689. Now we have to find the answers that go with negative 0.289. So that means x equals the inverse sine of negative 0.289. And again, we will have two solutions. So on your calculator, second sine, negative 0.289, we get negative 0.293 plus 2 pi n. And then we want our other answer, which is going to be pi minus negative 0.293. And so second pi minus second answer gives you 3.435 plus 2 pi n. So notice, because we had two initial answers, that was like having the plus or minus 1/2 in that other problem. You actually end up with 4 potential answers. So this one gave us that. Now we want all the answers. This is what is called your general solution. What we want is the particular solution, that is all the values between 0 and 2 pi. So notice 2 pi is about 6.28. So it's like saying give us all the answers between 0 and 6.28. So all of these are going to fall in that range except for the negative. And if I add 2 pi to any of them, it will put me outside. 2 pi plus something positive will be beyond our range. So I already know that my first answers will be 0.76, 2.381, and 3.435. My last answer is going to come from the negative 0.293. So I'm going to let n equal 1, and that's going to represent 2 pi plus a negative 0.293, and that gives you 5.99. So this answer came from doing negative 0.293 plus 2 pi times 1. All the other ones came from adding 2 pi times 0. And there's our 4 answers. All right? So I hope, if you had any confusion about today, I hope this video helped.